Okay, so here's an alternate method for finding the same answer we just did. I start with a picture of it. I see that square root of x minus 1, it's the square root function shifted to the right by 1. That's the area we just found, so we already know the answer, but we're going to try it again. It goes from 1 to 5. That was the answer that we found, or the way this problem was set up before. But now, first thing we're going to do is solve for x, and by that I mean solve the curve function, the curve equation for x. So I have to square both sides and then add 1, and I get x is equal to y squared plus 1. That's the same curve, just solved for x. I notice it is the top half of the curve, and that comes from the fact that it's the y equals the positive square root to begin with. So that's the curve solved for x, and then I need to figure out the limits of integration as y values. And so I need to figure out what the upper and lower y values are. But I know the curve, so I can quickly figure out that the top value is a 2 for y by plugging in x equal to 5. That gives me 5 minus 1, square root of 4 is 2. And I can see that the bottom value is a 0 for y. That's because if I plug in a 1 for x, I get square root of 0 is equal to 0. All right, so now here's the answer below. But let's look at the picture on the left to see how I got this answer below. Same picture, but now I'm thinking about it going from 0 to 2 on the y-axis. That means that I'm slicing up that area into horizontal strips. Typically when you do a normal integral with respect to x, you slice it into vertical strips, but there's no reason why you couldn't slice it into horizontal strips. And that means we can write the integral in terms of y. So that means it'll go from 0 to 2, and then now I'm going to have to do a subtraction because that curve doesn't go all the way. I'm not looking for the area in between that curve and the y-axis. I'm looking for the area that I already found. I'm looking for the area between the curve and the line, the vertical line, x equal to 5. So it's an area from 0 to 2 of 5 dy. That would be the whole area all the way from the y-axis over to the vertical line, x equal to 5. And I'm going to subtract the area from 0 to 2 of that y squared plus 1 dy. And the area I'm subtracting would be the area from the y-axis on the left over to the curve on the right. You have to think of everything like with your head turned to the side now. And that same area should come out. Well, let's see that it does. So just treat the y as the variable that you're integrating with respect to. In other words, you find the antiderivatives with respect to y, just like as if it was an x. So first part there I did do a little bit quickly. You could find the antiderivative as 5y. And then you can plug in a 2 and a 0, and you see that it's 10. Also, you should notice that the area from 0 to 2 of 5 dy is the entire rectangle. So it's 2 times 5, which is 10. And then now this integral is the portion that I'm subtracting because it's the part that goes from the y-axis on the left over to the curve on the right. So it would go from 0 to 2, the integral y squared plus 1. That's the curve solved for x. With respect to y, dy. You can think of dy as the little vertical thickness now. Alright, so then you raise and divide, and the 1 becomes a y because it's with respect to y. Then you plug in the 2 and the 0, and I did that kind of quickly there. You plug in the 2, you get the 8/3 plus 2. So 8/3 plus, what would that be? 6/3. And then you do have to plug in the 0, which gives you all zeros. and then you have 10. So you have 20, oh, let's see, no, 10 would be 30 thirds minus 14 thirds. And the answer comes out to 16 thirds, like we thought. One more way that you could do it is that you could write it all as one integral. Just make it be the integral from 0 to 2 of the 5, that's that vertical line, minus the curve, y squared plus 1. You can see real quickly that this comes out the same as the one that I just did. It's just that I'm writing it all as a single integral. And that works out nicely because you can even simplify before you start. 5 minus 1 is 4, so you get 4 minus y squared. Then the antiderivative of that would be 4y minus y cubed over 3, raise and divide again. Then plug in the 2 and the 0, and I get the 0 gives me 0, and the 2 gives me the 8 minus 8 thirds, which comes out to 16 thirds again. That would be 24 thirds minus 8 thirds, so 16 thirds.